Hey there, Charger people, it's Mrs. Boyd coming at you talking today about trapezoids and kites. Let's first of all say what a trapezoid is. A trapezoid is a quadrilateral with only one pair of opposite sides which we're going to call bases parallel. So this is a trapezoid here on the right. These two opposite sides are parallel, so we can mark them like this. The other two sides are not parallel. In fact, this one has a positive slope and this one has a negative slope. There are three different kinds of trapezoids. There is this guy that only has the parallel bases, and that is just a normal run-of-the-mill trapezoid. And then there's a trapezoid where these two bases are opposite, and the two opposite sides, other opposite sides are congruent, and the two angles that are on either side of each base are congruent to each other. So the two top angles are congruent, and the two bottom angles are congruent. Lastly, with this kind of trapezoid, if we were to give it some diagonals, like so, those diagonals are congruent, all right? This is an isosceles trapezoid. One more kind of trapezoid coming at you. This one is a trapezoid because these opposite sides are parallel. Other difference here, we've got two vertices that are right angles. This is a right trapezoid. All right, let's do a little example here and see if we can learn some more about what we do with these trapezoids. So determine whether the figure is a trapezoid and if it's isosceles. So first thing we're going to do is graph this puppy. A is at -3, -1. B is at -1, 3. C is at 2, 3. D is at 4, -1. All right, let's connect the dots here. The first line was real, oh, that one was awful. Let's try again here. That one's only marginally better. Whew, boy. All right, step one, check for only one pair of congruent slopes. Well, we need to look at the slope of BC. We can tell because it's a horizontal line, that slope is 0. We're going to look at the slope of AD, also horizontal, also a slope of 0. Let's look at the slope of AB. So we go 1, 2, 3, 4 up, and 1, 2 to the right. So 4 over 2 is slope of 2. Slope of CB. Of course, you could use the points and calculate it that way if you want. I'm just going to count the lines here. We're going to go 1, 2, 3, 4 down. So that's a -4. And 1, 2 to the right. So that slope is -2. These two are not congruent. So this checks out, only one pair of congruent slopes. So yes, it's a trapezoid. Next question. We want to know if it's isosceles. Well, to do that, we check the distance of the diagonals. Let's see where the diagonals are. One diagonal is connecting A and C. So the distance of AC is going to be this big long distance formula. The difference in the y's, -3 minus 2 squared plus the difference, that's the difference in the x's squared plus the difference in the y's, -1 minus 3 squared. That is 5 squared, actually -5 squared, plus -4 squared. That is 25 plus 16. That's the square root of 41. Same idea, but this time for BD. We want the distance of BD. The difference in the x's squared, -1 minus 4 squared, plus the difference in the y's squared, 3 plus 1 squared. That is -5 squared plus 4 squared, or the square root of 25 plus 16, or square root of 41. So yes, those diagonals have the same distance. That means this is isosceles. All right. Now, the median of a trapezoid is equal to the mean of the bases of the figure. So if we want to see what this means, this is the median here in the center, like the median is in the center of the road. The median and a trapezoid is in the center of a trapezoid. It's in between the two bases and parallel to those lines. It splits each of the other sides of the trapezoid into two congruent parts. We're going to call this base 1 on top and base 2 on the bottom. It doesn't matter which one is which. You could name them either way. But I like calling the one on top B1. The equation for the median is base 1 plus base 2 over 2. And like I put on the shape, the median bisects the sides of a trapezoid. All right. That is all we're going to know about trapezoids. We're moving on to kites. It looks like a kite, right? It's what you'd think it is. A kite, by definition, is a quadrilateral with two pairs of congruent consecutive sides. Whoopsie. Perpendicular diagonals and only one pair of opposite angles are congruent. So let's kind of break down what that means on our shape here. It has two pairs of congruent consecutive sides. So consecutive means they come one after the other. So these two right next to each other, congruent. These two right next to each other, also congruent. Next, it says there's perpendicular diagonals. Well, these are the lines that are the diagonals. Oh, my drawing is horrible. And they are perpendicular, which means they form a right angle. There's only one pair of congruent opposite angles. That means this angle and this angle are congruent. The other two angles are not congruent to each other or anything else. Okay? That's kites in a nutshell. Let's look at this figure, A, B, C, D on the right. we want to find the measure of angle CED. Well, CED is made up of the diagonals, and we know that the diagonals make a right angle. So the measure of angle CED is 90 degrees. Number 2, if EC equals 3 and ED equals 10, find CD. Well, we're going to use a good old Pythagorean theorem. And we're going to say that A squared plus B squared equals CD squared. Well, that's 9 plus 100 equals CD squared. That's 109 is CD squared. We don't want CD squared, we want CD. So we'll take the square root of each side, and we get CD is equal to the square root of 109. Next, maybe, get my pen to work here. If the measure of angle ABC is 90, I don't buy that ABC is 90. Oh, okay, yeah, ABC is 90. That means that's a right angle. And the measure of angle ADC is 110. Find the measure of angle BAD. Okay, so we're going to have to look at these as two isosceles triangles, and they're going to be split up by this purple line, this AC. If angle B here, ABC, is 90, we can say 180 minus 90 is 90. So in this triangle, 90 degrees are taken up here, and these other two angles have 90 degrees to split between them. Since it's an isosceles triangle, we know all we have to do is to divide that 90 by 2 and get BAC is 45. And BCA is also 45, but that doesn't matter. Same thing can happen in this bottom triangle. Angle ADC here is 110. That means we can say 180 minus 110 gives us 70, and we have 70 degrees left to split between these two angles. And we know that we can divide 70 by 2 and find that each of those angles are 35 degrees. Now, to find the measure of angle BAD, all we have to do is add those two angles together. So the measure of angle BAD is 45 plus 35, or 80. And consequentially, it's also the measure of angle BCD. Looking at the same figure, if BC is 7, find AB. Well, these two are congruent, so AB is also 7. I'm going to scroll down to see this next image. We'll move back up. If AB is 7 and AE is 5, find BE. Well, AB is 7, AE is 5. This is another case of the Pythagorean theorem. But now we have 5 squared plus BE squared equals 7 squared. That's 25 plus BE squared is 49. We subtract 25 from each side, and we get BE squared is going to be 24. And we take the square root of each side to get that BE is equal to the square root of 24. Last but not least, if the measure of angle ABC is 52, we're going to have to erase some stuff here. Okay, if ABC is 52, And ADC is 95. Find the measure of angle BAD. We're going to solve this one a little bit of a different way than we did the last one. And I just wanted to give you two different options as to how to solve these. This trapezoid has 4 vertices, 4 sides, 4 vertices. That means the sum of the interior angles is going to be 360. So if we add these angles up, we should get 360. So we know we can add 52 plus 95 plus, and now we're looking for the measure of angle BAD. Well, BAD is this guy here, and we know that only in kites, I call it a trapezoid, it's a kite, only in kites are these two opposite angles the same. So BAD and BCD are the same. So instead of worrying about what BCD is, we're just going to say 2 times the measure of angle BAD will equal 360. So we can combine like terms over here. That's 147 plus 2 times the measure of angle BAD will give us 360. We can subtract 147 from each side. And I get 2 times the measure of angle BAD is 213. Divide both sides by 2. I get the measure of angle BAD is 106.5. I hope this makes all sorts of sense to you. Reach out if you have any problems or questions, and I hope to see you soon.